to geometry. This is section 4.4. We're going to talk tonight about triangle congruence. We've already talked about congruent triangles. Tonight we're going to take it a step further. We're actually going to look at a couple of different ways to prove triangles congruent without going through that entire process we did last time. It takes a little bit of time to go through and say every single piece is congruent. So instead we're going to look at a couple of shortcuts. How do we get directly to triangles being congruent without going through every single possible piece? Okay, our first postulate for the night. We only got two, so it's a short night. First one we got is side-side-side postulate. I know in your notes it says SSS. Everybody uses the abbreviation, but it's technically side-side-side. The way it works is basically it's saying that if we have two triangles, and we know that all three pairs of sides are congruent. So we've got, on our little triangle there, you got AB is congruent to DS. You've got AC is congruent to EF. AC, EF. And then, of course, we've got BC is congruent to ED. So you can see that we have three different pairs of sides that are congruent. So basically what this postulate is saying is that we don't have to worry about the angles. If we know all the sides are the same, then we're going to end up with the same triangle. So three sides congruent is enough to say that the triangles are congruent. You don't have to worry about the angles if you know about all the sides. So let's do a quick example of this. Here we've got a proof. We did proofs last time. We're going to do proofs again. We're going to continue to do them throughout this unit. We're going to look at side. So we have two things that are given to us. The first one is that PQ is congruent to PS. And you'll see it's already marked there on the little diagram, PQ congruent to PS. We know that QR is congruent to SR, also already marked in the picture for us. And we're trying to prove that those two triangles, PQR on the top, PSR on the bottom, we're trying to prove those are congruent to each other. So here we go. It's going to be 4 steps. First step, I'm always going to start off with my given. So I know that PQ is congruent to PS. As the very first given statement, I know that. It's a statement. My reason is it's given. Next one, we got QR is congruent to SR. Once again, given statements. Those are out of the way. We have two sides congruent. We need a third side. You can see that those two triangles, they actually share that side PR. So I'm going to say that PR is congruent to RP. I know I rearranged the letters there, but really it's saying that that segment is congruent to itself, which is kind of a silly thing to have to say, but it does give us our third side that's congruent on our two triangles. So I'm going to go ahead and mark that 1, 2, 3 little dashes. 3 little dashes. I got those sides congruent as well. My reason, I can't just say, well, duh, it's the same side. I have to have a geometric reason because you know how math people are. We always have to have a fancy way to say it. The fancy term to say that something is congruent to itself is to refer to this reflexive property thing. So anytime you're saying something's congruent to itself, the term for that is reflexive property. And if you want to know more about the reflexive property, I'm more than happy to tell you about it in class, but really all it is saying that something's the same as itself. It's like 2 equals 2, X equals X. PR and RP are the same segment, so they are congruent to each other. So now I got 3 different pairs of sides that are congruent. So I got QP and PS, and then I've got the QR and SR, and then now I've got the PR is congruent to RP. So that's enough to say my triangles are congruent thanks to SSS. All 3 sides congruent means the triangles are congruent. Moving on. Second postulate of the night, side angle side postulate. SAS is what everybody uses to say it because no one likes to say the full thing out. You'll find that a lot. There's a lot of acronyms and this triangle congruent stuff. So we're going to start off with SAS, and once again we're trying to prove 2 triangles are congruent without having to go through the entire process. So this time I have, if 2 sides, so I got 2 pairs of sides here. I got AB is congruent to EF, you see little tick marks there, and I got another side, AC is congruent to ED, I can see another pair of tick marks there, but I don't have the third side. Instead, I have what's called their included angle. So that angle that they form when those two sides meet up, so the included angle is the one that they're forming. So two sides and the angle between them is the same on the two triangles, then the triangles are the same. Okay? Once again, two sides with an angle in between are the same on the two triangles. We have congruent triangles because that angle tells us how much we can open up. So there's only one option for that third side. It has to be that far open, which means they have to have the same length. Let's use it in an example, another proof. This time I got a fancy little picture. It's actually a little like, you know, a couple of boards going together. If you were to look in the textbook, you'd see this picture, and they say it as this, you know, scaffolding thing inside the Statue of Liberty. I'm just going to focus on the fact that it's a whole bunch of triangles all mixed up, and I'm going to try to do some proof here. So I've got my two given statements. I got KP is congruent to LP. I can see that. It's marked. They're kind of, it looks like P is going to be the midpoint is another way to say that. And then I got NP is congruent to MP. Once again, I got P as the midpoint. So you got P acting as the midpoint for both of those. Let's start off our proof trying to prove that KPN, the triangle on the left, is congruent to LPM, the triangle on the right. So let's start off with our given statements. I got KP congruent to LP. Once again, reason for that, it's given. It's right there. And we got the other one, NP congruent to MP. Once again, given. It's already on the picture for us. Now we have the two sides. I need to somehow get that angle in the middle. I need to somehow get that angle that makes the bow tie there in the middle. If only we had a term for angles that are non-adjacent at an intersection. Oh wait, we do. They're called vertical angles. It's Mr. Olivier's absolute favorite angle. It makes the little bow tie on the picture. Vertical angles, there we go. KPN and LPM. They are congruent. KPN is congruent to LPM because vertical angles are always congruent. There's absolutely nothing we can do about it. They're going to be the same. So the reason that those two angles are congruent is that they are vertical angles. You have vertical angles on there. We're good. All right, so now let's just do a double check. I've got my vertical angles. I've got the sides on either side of them. That looks just like my picture for SAS. Side, angle, side, side, angle, side. I'm looking good. I'm going to go ahead and say that KPN is congruent to LPM, this time the triangles, and that's an SAS. That's the reason. So I've got an example of SSS. I've got an example of SAS. It's basically the same thing we did last time with the triangle congruence, but we're doing shortcuts here so that we can get straight to the point without having to prove every single little piece of the triangles congruent to each other. Stay tuned for more of these coming to a geometry class near you very soon. Thank you very much. Have a good night.